Hello guys, welcome you all to the 8th session of exploratory data analysis. And today our agenda is to discuss univariate analysis. So let's start our discussion. So if you remember, during the last session, we have discussed and plotted histograms and probability density function of petal length. This is the histogram and probability. This is the probability density function of my on petal length. Now, to actually start the univariate analysis, what we need to do first, we need to plot the histogram and probability density function on petal width, sepal length, and sepal width as well. So this is very easy because we do not need to write anything new here. Simply in this code, if you look at this code, this is called petal length. This here you have to change the name from petal length to sepal length, then petal length to petal width, then sepal length and sepal width. This is the only changes that you have to make, nothing more. Here also instead of this petal length, you have to put here petal width, then sepal length and sepal width. So what I have done, I have just copied these two codes and I have changed the name from this sepal length to, let's see, I have copied before the class starts. I have copied this to save our time. You should also copy and paste your code and simply change the. So what we have done right now, we have plotted histogram on petal width, sepal length and sepal width. Fine. Now let's understand how we can use this simple concept of histogram, how we can use this simple concept of histogram and PDF or probability density function to do something called univariate analysis. What is my agenda? To do univariate analysis. And what is this univariate analysis? Univariate analysis. And what is this univariate analysis? Now, as the name suggests, uni means one variable analysis. This is univariate analysis means one variable analysis, right? So I have a sepal length, I have sepal width, I have petal length, and I have petal width. These are my four variables. Now, I want to understand which of these four variables is more useful in distinguishing my setosa, versicolor, and virginica flowers. We have three flowers. Let's imagine that's a question that I want to answer. And we can answer that question using simple univariate analysis. Simple univariate analysis. And how we will do this univariate analysis? I will do this univariate analysis using my histogram and probability density function. So let's see how to do it. First, what I have done here is basically, first thing is that I have done here is my histogram on petal length. This is my petal length and this is the histogram on petal length. And if you see, this is the probability density function on my petal length. Fine. So the x-axis here is the petal length and y-axis is basically, x-axis here is the petal length and y-axis is basically the histogram or the counts of value. That is all the histogram is. Basically, histogram shows you the count of the values on any particular bucket. Fine. We need to understand which of the four variables is more useful in classifying flowers into setosa, versicolor, and virginica. So if I have to pick just one feature, which of the four is most useful? We have four features: sepal length, sepal width, petal length, and that. If you see the petal length, you will notice this. You will not find a setosa flower beyond a value of 2. There is no setosa flower beyond a value of 2. And because my whole distribution is here, this is my setosa, this is my versicolor, and this is my virginica. So my setosa is well separated from my virginica and versicolor. You can see this. That's the first thing that you will notice. And second thing that you will notice here is there is some overlap between versicolor and virginica. This is the reason of overlap. You will see this is the reason of my overlap. This is a small overlap. This is the second thing. Because the overlap is only this much, we can't run away from it. So what would have been the perfect case? The perfect case would have been that all of my setosa flowers, let's say this would have been my perfect case. All of my setosa flowers will be here. All of my versicolor will be here. And all of my virginica will be here. This would have been my perfect case because here there is a clear separation between these three flowers. That would have been my perfect case. Now, if all three of them are well separated, that would have been the best case. But that's okay. What I have here is fairly good. I have some overlap here, but that's fine. We will deal with it. So this is when I use petal length as my feature. Fine. Now, let's see what happens when I have petal width as my feature. So let's come to this petal width. So this is my petal width. Fine. So when I see petal width, I notice that in petal width, these two, if you come here to the PDF, these two, setosa and my versicolor, are just intersecting. So my setosa is fairly well separated from my virginica and versicolor, but there is a small intersection at this point. So the thumb rule or the mathematical foundation here is the farther these distributions are, the better. So the farther these distributions are, the more well separated this distribution is called. This is a better one. The more separated it is, the better they are. So if it would like this, if let's say we have the three distributions like this, and the farther these distributions are, let's say, the farther these distributions are, better these distributions are. And the closer these distributions are, they are not much better, or they are not much more useful for us. Is the thing clear? Now, there is a small intersection and there is of course some overlap here also. There is some overlap. Can you see? There is some overlap here also. And there was some overlap in the previous petal length also. So this is a reason of my overlap. So this is almost as good as it was in the previous cases. Roughly it is same thing. Now, if I have to choose between, let's say if I have to choose between petal length and petal width, what's if I have to choose between petal length and petal width, this is my petal length and this is my petal width. So I would probably pick petal length because at least setosa is in the petal length, at least setosa is well separated from my versicolor and virginica. So that's why I'm going to pick petal length as my future feature. Now, this is the one thing. Now let's go and look at what happens if you use sepal length. So let's come to the sepal length and see. This is my sepal length. Now, if you just look at this sepal length, it looks very scary. If you look at the histogram of sepal length, there is a massive overlap here. Your setosa flower itself is not well separated from versicolor and virginica flowers. There is this much overlap. This much overlap is there. Fine. And there is also overlap between setosa and virginica. This is setosa and this is virginica. So setosa and virginica, there is also overlap between setosa and virginica. If you will see here, you can see it clearly. Can you see here? If I will tell you this, can you see? This is my setosa, and this whole there is a overlap of setosa and versicolor. This much overlap is there. Fine. And also there is the overlap of this much overlap is there between this virginica and versicolor. Virginica and versicolor is having this much overlap. Can you see this much overlap is there between virginica and versicolor? Fine. This much overlap. Also, there is an overlap of this much overlap is there between setosa and this virginica. So you can see here. Now, the closer these distributions are, the more overlapping these distributions are. So if you look at versicolor and virginica, if you look at this versicolor and virginica, the overlap is massive. Can you see? Overlap is massive, overlap is there. Massive overlap is there. So the overlap in this whole region, if you put the whole region together, the overlap in this whole region is massive. So sepal length, if I have to pick, so till now we have seen till now my petal width is much better than my petal width. Petal length is better than my petal width. Now this petal width is, I can say, much better than my sepal length. Much better than my sepal length. Now let's go and see at sepal width. We have seen sepal length. Now let's see sepal width. Let's erase this so that we do not face any issue. Fine. So if you will come and see the sepal width, let's come to see sepal width. Oh. So when I see this sepal width, this is really bad, because if you look at my setosa is in fact here. If you look at virginica and versicolor, this virginica and versicolor, they are like there's a fully overlapping. The virginica and versicolor are fully overlapping. The whole reason is, in fact, if you see, it's like they are on top of each other. They are literally on top of each other, right? So there is a whole reason of overlap. which means it's a terrible situation to be in. Even your setosa is not well separated from your versinica and versicolor. So just, can you see how the situation is? How this terrible situation it looks like? So just by looking at these 4 histograms or PDFs, my conclusion would be like that. I can conclude like that. My petal length is slightly better than my petal width. My petal width is much better than my sepal length. And this sepal length is much better than my sepal width. So this is my conclusion by seeing at the histogram and PDF. So you can see petal length is significantly better than the sepal width also. Right? And this sepal length is also significantly better than this sepal width. Sepal length is significantly better than this sepal width. So if I have to pick one feature, I would pick petal length. I would pick this petal length. If I have to pick one feature out of these 4. Now, if I have to pick 2 features, I will probably pick petal length and petal width. These 2 features I will pick first, and these 2. If I have to pick 2 features, in that case. Fine. And of course, when I will pick 2 features, I also look at pair plots. And we have learned the pair plots. I will also look at the pair plots that we saw earlier. So to choose which these features are most useful in separating one type of flowers from the other types of flowers. So we have understand this. Commit the code to GitHub. So what we have discussed today, univariate analysis. Commit, yes, sync changes. Okay. Thanks, guys. Hope you are enjoying these sessions, and keep learning, keep smiling, and keep commenting. Thanks. Take care. Bye-bye.